Okay, the next problem is this one here, solving this rational equation. Now, whenever you have fractions and an equal sign, it's called a rational equation, we want to clear fractions. So you want to multiply through by the least common denominator. There's other ways to do it. You could add these fractions together by getting a common denominator, and then cross multiply the proportion you'll have left over. But that way's longer. The easier way to do it is to clear fractions by multiplying through by the least common denominator. Now keep in mind that this is really x minus 1, x plus 1. So that's what we need to multiply through by so that everything will cancel. So I'll write that up top. And so now what we'll have is that this will cancel. Use a different color. This will cancel. And I'll have left over on the left side 2x plus 3 times quantity x plus 1. And then this whole thing will cancel, top and bottom here, so I'll just have 10 on the right side. And then x plus 1 cancels with this x plus 1, and I have left 2x minus 3 times x minus 1. Now from here it's just a linear equation, well, actually a quadratic, but it's not a rational equation anymore. We do have to FOIL both these parts, so this becomes 2x squared plus 2x and 3x make 5x in the middle, and then plus 3. And then over here, if I FOIL this, I get 2x squared, and then minus 2x and minus 3x make minus 5x plus 3. Now some things cancel, which is nice. This 2x squared and this 2x squared are going to cancel. So then it becomes a linear equation, which is really nice. Now I'll move everything to the left. So I'm going to add 5x, so this becomes 10x on the left. 10 and 3 are 13, but I'm going to subtract 13 from this 3. And that gives me negative 10. And that equals 0. Or better yet, just keep it over here. And you have 10x equals 10, so x equals 1 is my answer. Now, make sure you double check that and make sure it's not extraneous. The problem with that answer is that if you plug in x equals 1 right here, you get an undefined answer. So this is extraneous. It looks like the answer key is wrong for this one, but this should be right as long as I don't make any mistakes here. X equals 1 would be the solution, but it happens to be extraneous, so let's make sure we say that. Okay, next topic is on right triangle trigonometry. The first question says that if we have a point on the terminal side of an angle, we want to find all the 6 trig functions of the angle. So we're going to draw a picture first. So negative 2, 1, 2, 3, 4 is the point. And the terminal side of the angle means we always start from this being 0 degrees, terminal side then being at that point. So we're looking for this angle right there. We want the 6 trig functions of that angle. So what we're going to do is make a reference triangle with the x-axis where this is 2 and this is 4. And now I'm going to use the Pythagorean theorem, which is 2 squared plus 4 squared equals c squared. So that'd be 4 plus 16, so this would be 20, and we can take the square root, so this is the square root of 20. Right here, we'll just leave it as the square root of 20. Now, I'm going to make this negative just because I'm going back right there. I know it's representing a length, but in this case, I'll make it negative to represent I'm going back. So now, the 6 trig functions, you have the cosine of this theta is adjacent over hypotenuse, which is negative 2 over square root of 20. So the reason I made that negative is because you might forget that and make it 2 over the square root of 20, which would be positive x value, which is what the cosine is representing. So you want to make sure that it's negative. All right, and then just follow through with this. Sine is opposite over hypotenuse. Tangent is sine over cosine, or opposite over adjacent. So it'd be 4 over negative 2, which is negative 2. And then just reciprocate these. So cosecant goes with sine because there has to be a co in each pair, in which case this was just the reciprocal, square root of 20 over 4. Secant is the reciprocal of cosine, which would be square root of 20 over negative 2. I'll put the negative in the numerator. And tangent would be cotangent, is the reciprocal of that, which is negative 2, or 1 over negative 2, negative 1/2. Okay, the next question gives us some clues about where this angle is. It says the cosine is negative 5 over 13. It's in quadrant 2. So I'm going to draw a reference triangle in quadrant 2. That's bad. Let me redo that one. And the cosine is adjacent over hypotenuse, so I know those two sides. Now I can find this side by using the Pythagorean theorem. Negative 5 squared is 25, plus I'll call this b for now. equals c squared. All right, so this is 169, and then subtract 25 from both sides, 144. So b is 12. If I square root both sides, so now that I know this is 12, I can find what they're wanting me to find, which is sine and tangent. So sine of theta equals opposite over hypotenuse, so that'd be 12 over 13. And tangent of theta is opposite over adjacent, which is 12 over -5, so -12/5. Okay, the next question is just recognizing a trig identity, which is that sine squared of some angle minus cosine squared of some angle. I'm sorry. Let's not do that. Let's just evaluate these, because the cosine of 5 pi over 3 is on your unit circle. It's 300 degrees. So on your unit circle, the cosine of that value is 1/2. So that would be 1/2, and that's going to have to be squared. And then 5 pi over 4 is also on your unit circle. That's at 225 degrees, or down here. And the cosine is negative square root of 2 over 2. That's going to have to be squared. So we just need to simplify that then. The negative goes away when you square it. Square root of 2 becomes 2. The denominator 2 squared becomes 4. And then this becomes 1/4 if you square the top and the bottom. So just subtract 2/4 minus 1/4 would be 1/4, which is your answer. Okay, the last section then, solving trig equations. We want to solve this equation in the interval from 0 to 2 pi. So where does the sine equal 1/2? Well, the sine is the y value, so it equals 1/2 here and here. Now, this is pi. This is 30 degrees, or pi over 6 on your unit circle. And then this one over here is 5 pi over 6. So we've got those two angles in radians, which is, they gave us radian intervals. They want us to use radians. Obviously, we could use 30 and 150 if we were in degrees. These are the two spots they're looking for. Technically, there's an infinite number of solutions, because, you know, every time the sine, if you're at this angle, the sine's 1/2. If you're at this angle, the sine's 1/2. And then if you rotate all the way around back to this, you're back at a sine value of 1/2. It's just that they told us to stick in the interval from 0 to 2 pi, in which case we just have these two solutions. Okay, then one last question here. Let's solve this one. We can actually factor this into a difference of two squares, sine of x minus cosine of x times quantity sine of x plus cosine of x. If you recognize that, it's actually the same pattern as x squared minus 4, where you have a difference of two squares. This factors into x minus 2x plus 2. So you just take the square root of both these things and put it here and here, and then change the sign in between them, which is exactly what we did here. So this still equals 0. So basically what we want then, if you set each of these factors equal to 0, this one would be where the sine equals the cosine. And that's on the unit circle. That happens here, where they're both square root of 2 over 2. So that'd be pi over 4 degrees as one of our solutions. And then it also happens again down here, where they're both negative square root of 2 over 2. And that happens at 5 pi over 4. So we've got those two solutions from this part right here. Now let's do the other part, which is over here. That's where they're opposite, so that's where the sine of x equals the opposite of the cosine. And that happens here, where one of them is negative square root of 2 over 2 and one of them is positive square root of 2 over 2. So that'd be 3 pi over 4 on your unit circle. And then the last one is down here, where one of them is positive, one of them is negative, but they're both still square root of 2 over 2. And that it would be 7 pi over 4. So that would be 4 solutions. Now, what's tricky about this is they don't give us an interval to solve the solutions, unless it's under the same directions, which actually I think it is. We want solutions between 0 and 2 pi, so we'd keep just these 4. Technically, there's an infinite number of solutions if we don't have that stipulation, but we want to use that stipulation, which is that the angles have to be between 0 and 2 pi.